me just zoom in here.
The one we did was not related to calculus, was it?
No, but this one now is. There we go. Question? No? No. Okay. So this next method now is a method that is on the exam. They could ask you to find the slope of the tangent using something called first principles.
I'm sorry, last question. So you don't want us to do any other questions but 2C? Any of them?
Yes.
That's
2C. Right. Next. So another way we could find the slope of the tangent is if we had a second point, but there is a little bit of a problem. Let's take a quadratic like this. Y equals x squared. And let's just choose a point here. We'll say x equals 1. And we draw the tangent line at x equals 1. Tangent line. Close enough. At x equals 1. Right. X equals 1. Okay. So you know from chapter 1 that if you want to find the slope of a line, you would need to have a second point on it, which we don't have. But we do have one point. When x equals 1, what is y equal to? 1. So we have the point 1 and 1 on it. But we do not have a second point. But we can roughly find a second point. The idea is we look at the point a little bit to the right of x equals 1, for example. So we look at the point x plus delta x. And delta x is a small value. But it's not important right now what the value is. It's just a small value. So we move a little bit to the right. Now, we do not know the height of this point, but we have the height here on the curve. Yeah? And that's only a little bit higher than the point we really want. So it's not perfect, but I could use this point instead. But it won't be exactly right. So, for example, on the second point, if we have x plus delta x, what would the y be? Yeah, and actually, in this case, I actually know what this x is. I should write it in. It's 1. So if this is 1, then its neighbour would be 1 plus delta x. So this here is 1. And the y value? 1 plus delta x squared. So this is the first point and this is the second point. Here is 1 and here is 1 plus delta x. And the height would be 1 plus delta x squared. That's this height, not this one, but it's close, so it'll do. For this one here is this height up here. We really want this one on the line. So there's a small error. So let's calculate the slope. We know it'll be y2 minus y1 over x2 minus x1. So this will be 1 plus 2 delta x plus delta x squared minus 1 over delta x plus 1 minus 1. So on the top, what am I left with? 2 delta x plus delta x squared, and on the bottom, delta x. So this will be 2 plus delta x, is what I'm left with. Now, there is a problem. This answer won't be perfect, because we don't want this point, we want this one here. But suppose I made delta x a smaller number. Let's imagine for the moment delta x here was 0.0001. It's a little to the right. Yeah, a little to the right. So if I want this to be more accurate, I should use a point that's here. because if I zoom in, you can see this one is closer to the line than this one here. So should I make the delta x bigger or smaller if I wanted to be more accurate? Yeah, so in other words, the smaller I make this, the more accurate my answer. Correct? What would happen if I made this go all the way to 0? How many points would I have now on the curve? It would become 1 point, because if I made the delta x smaller, this point would move closer and closer until eventually the 2 points became 1 point then. So now it's no longer a secant, but it's become a tangent. So if I make the delta x become 0, what am I left with at the end? 2. Now for those people who've done derivatives before, which we will do soon, what's the derivative of this?
2x.
And if x is equal to 1? The same answer. Yeah. This method is sometimes asked for in the exam. It's called the method of first principle, and we'll definitely do another example. So if you can write this one down as your first method. Yeah, we'll do another example. We'll do another example.
Should I call that dy here?
Yeah, well, I was just about to say about that, what to call it. Okay, can I scroll down a little bit? Yeah. So, here. So, we call this the slope, but delta y, delta x, we use this to mean the approximate value of the slope. So earlier we said this was the slope, but of course it's not perfect, there's a small error. If I make the delta x become 0, it then becomes perfect, and then we use this symbol to represent the slope. So in other words, to go from here to here, what happens to the delta x? It becomes 0.
Yeah.
So this is like the slope before the delta x is 0, and this is it after the delta x is 0. So of course, really this is the accurate one, and this one has a small error in it. We'll do another example for sure. Can I scroll down?
Yeah.
Quickly. Okay. Right, let's have a look at another one. So let's say this time we have something like some curve like this. We'll say y equals, let's say, minus x squared plus x. Will this look right? 0 will be 1 and 1. Okay, so we'll have this one here. So what I want is, I want a formula for the slope of the tangent, and I won't tell you what point this time. I'll just call the point here x. Well, let's just put it here, it'll be a little easier to draw. So we'll put the point here, x. So I want the slope of this tangent line here. So again, we use the same trick. We look at a neighbour. So the neighbour here would be x plus delta x. This time, I'm just going to use a different letter, because in some books they use delta x, but in some books, maybe you've seen it this way in high school, they use the letter H.
No.
No, well most people, yeah, some people said yes. Some people use delta x and some people use H. So just so you can see both, I'll use H this time. So the neighbour is x plus H. So let's look at the 2 points. The first point here will be x and y, but we know what the y is. It's minus x squared plus x. So this is the first point here. The second point, which is here, what would that be? So this is the first one, and the second one is x plus h, and then what's the y? Minus x plus h squared plus x plus h. So this is like x1, y1 here, and this one is like x2, y2 here. And let's calculate the slope of this one now. Okay, can I scroll down? Yeah? Oh, come on. I'm scrolling down now. Right. So the slope y2 minus y1, so that's minus x squared minus x over x2 minus x1. So on the top, here? Yeah, minus will make plus, yeah. I'll write that in on second one's minus. Are you sure?
I think because you times the minus, right?
This one is y2. We're happy with this part, yeah? And then minus this. So minus makes that a plus. And that's a plus. So when I minus it, it'll become a minus.
Yeah.
That's what I did, yeah. If you prefer, I can use brackets. So I'll put brackets here and then write this as a plus. Preferred? Yeah. Okay. So on the top, I'll get minus x squared minus 2xh minus h squared plus x plus h plus x squared minus x. And then on the bottom, I'll just get h. So on the top, let's see, minus x squared and x squared cancel. Minus two, x and minus x cancel, so that goes with that, that goes with that, so we're left with minus 2x, we're left with h minus 2xh, minus 2xh minus plus h squared, oh my goodness, what's wrong with me? Minus h squared plus h all over h. Okay. Now, because h is in everything, we can divide, yeah? So minus 2x minus h plus 1. Or if you want, that's minus 2x plus 1 minus h. That's the slope. Now, how can I make this answer more accurate? Make h smaller and smaller. In fact, make h go all the way down to 0. What's happening, you're moving the point closer and closer together, so it starts to become a tangent instead of a secant. So if you want to calculate the derivative, it will be equal to minus 2x plus 1. If you want the slope of the tangent, it's minus 2x plus 1. In this case, I didn't give you the x, so you have to leave the answer like this. But often they'll give you the x, so they might say when x equals 2 or something. Yeah.
Why do we do this method?
Huh?
Why do we do this method? In the end, we get the same answer as using normally.
So what you're saying is, teacher, I don't trust you right now. Explain yourself. So like I said, in the exam, they will say, use first principles to find it. And you cannot say, hi, this is Nathan. I'm going to use a different method, so are we cool? Thanks. Alright? Won't get you the marks, okay? If they ask for the first principle method, that is the only thing that will get you the marks.
Yeah.
So you must be able to do it this way because it could be in the exam and it has been in the exam. So we do need this method for the exam. Okay? I'm going to give you one to try now using this method. Can I scroll down and give you the next one to try? Yeah. So you heard me use a word that you already know. But slope of tangent, this thing here, is called the derivative. But it literally means slope of the tangent. It's exactly the same as slope of the tangent. So if I said find the derivative, it means find the slope of the tangent. Yeah, the same thing. Okay, can I scroll down?
So this and the one delta y over delta x means slope.
Yeah, they're both slopes, and we call that derivative. Can I scroll down? Yeah. Right. So, yeah. Yeah, it's possible with cubic, but all the examples I can think of in the exam is quadratic. I think 99% likely it'll be a quadratic. There's only a very small chance it would not be a quadratic, but it's possible they might give you a non-quadratic. But I feel really confident in saying that it's going to be a quadratic because the cubic ones, they're longer because you have to expand it, and they're not testing that knowledge in the question, they're really just testing the first principles. So they'll give you something like a simple quadratic. So like the examples I can think of, one year they said something like 2x squared, and then in another year it was something like x squared minus 1. So this is kind of like what you get in the exam. But there is a small chance that it could be more difficult. So we'll look at one that's a little bit more difficult. I want, using first principles, find the derivative of this using first principles. Okay, try this one now. See what you can get for this. Okay, let's have a look at this one. So it is a little bit difficult. It is a bit difficult. So firstly, let's write down our 2 points we're going to use. So of course we're going to use x and y as the first point, but we know what the y is. If we have the x, the y is 1 over x.
Yeah.
And then we'll use its neighbour. So its neighbour is x plus h and 1 over x plus h. So let's calculate now the slope. y2 minus y1 over x2 minus x1. So y2 minus y1 over, and this will just be h. So we want to simplify this a little bit. This will be 1 over x plus h minus 1 over x divided by h, which is 1 over x plus h minus 1 over x multiply 1 over h. You remember this from elementary school, don't you?
Yeah,
When you divide by a fraction, you multiply by that. Yes. I know you do this in elementary school, so don't make your elementary school teacher sad. So here we can put these two fractions together. Now, I don't remember if I showed you this, but the way I put two fractions together, if I had, say, a over b plus c over d, quickly to put them together, it's bd on the bottom, and then ad plus bc, and if it was a minus, it's exactly the same. It'd be bd on the bottom, and then ad minus bc. So we can add the fractions together this way. So here, this would be x plus h times x, and then x minus x plus h. Because when we multiply by 1, nothing happens. Multiply by 1 over h. So on the top, I'll get x minus h over x plus h times x times h on the bottom. So on the top I'll have minus h, and on the bottom I'll have x plus h times x times h. Well, they cancel. So I have minus 1 over x plus h times x. So finally, I make the h go to 0, and what am I left with? Minus 1 over
x squared.
So this is the derivative here.
Sorry.
We'll leave it like this. Okay, write this one down. We'll have a look at one more example you can try.
So for the second derivative, for example y squared, it's just the x that's added on. So sorry, for the y2, it's,
yes.
If it's like let's say it's x squared, it's x squared plus delta x plus delta x.
All squared. Yeah. Okay. A little bit. No, don't worry. A little bit of notation. If the question said find dy dx, this is the answer. Of course, dy dx equals this. But sometimes you might see this in the question. They draw a line and they write at the bottom something like x equals 2. So what this means is find the derivative when x equals 2. So if that was the question here, if I said find the derivative when x equals 2, we write it like this: derivative line x equals 2. This means when x equals 2. So in this case it will be minus 1 over 4.
Yeah.
So that's what this notation means. Another way to write it is dy dx with square brackets, and then down the bottom x equals 2. So we don't really use that one. It's this one here. Yeah? We'll have another example.
You said before that when you use the plus and minus when we divide or times, I don't know what you You know the B and A is over there? We want to go to that. That's called the
Yeah? This thing?
Yeah, we didn't use it in this equation, do we?
We did.
Oh no, sorry, I'm just trying to where would we
Okay,
over here, okay, yeah.
try this one. If y equals root x, then find dy dx when x equals 1 using first principles. Actually, because of the time, I think I'll just go through it. So write this question down and then I'll do it now. You got that? Who did we say we're missing? Juliana, Hisham, and was there someone else? Oh, she emailed me. Yeah, that's okay. All right. Can we do this one now?
Yeah.
Abdullah, you wrote this down? Oh, come on. Right, let's have a look at this one now. So the first point will be x and y is square root x. And then the second point is x plus h and square root x plus h. These are the 2 points. Yeah? So the slope will be root x plus h minus root x over x plus h minus x. So that's root x plus h minus root x all over h. Now, the way I'll simplify this is by using a type of conjugate. What I'll do is, I'll multiply the top by root x plus h plus root x, and the bottom by root x plus h plus root x. Like the conjugate, remember? So, on the top, I'll get root x plus h by root x plus h, which is x plus h. Root x plus h by root x, so that's plus root x by root x plus h. Minus root x by this, so that's minus root x by root x plus h. And then finally, minus root x by plus root x is minus x. And then on the bottom, I'll get h root x plus h plus root x multiply. Now, quite good because on the top 2 things cancel. So on the top, well actually more than 2 things cancel because this cancels with this and x cancels with x. So I'm only left with h over h multiply root x plus h plus root x. Now what cancels? H is cancelled. So now I'm left with 1 over root x plus h plus root x. But what do we make h equal to?
0.
0. So now I'm left with 1 over root x plus root x, which is 1 over 2 root x. But now I tell you what the x is in the question. What did I say? X equals 1. So this will be 1 over 2 root 1. Which is 1 over 2. So this is the slope of the tangent at 1.
Sure.
Yeah.
Is it like a problem if you substitute 1 in the
No, you could have done that at the very
at the
beginning.
beginning?
Yeah,
Okay,
yeah.
that's good, yeah.
Did we finish the lesson or is there still more examples?
No, I think this is enough for what you need for the exam for sure.
But for the worksheet,
Oh yeah, well I'll tell you what to do in the worksheet now. Don't worry, I'm not giving you these peculiar ones in the homework. The 1 over x and the square root x is not on the exam. It's only ever going to be linear, quadratic, or worst case, cubic. But I think even if they did give you a cubic, it'll probably be a simple cubic, like just x cubed by itself, something like this. So your homework you should be able to do is on the first principle worksheet, all of question 2. So question 2. Okay, did you write that down? So for first principles, it's question 2 on the worksheet. Yeah. We have tutorial later. Yeah. Okay, can I close this?
Yep.
Yeah.